October 17th, 2025. A day that was supposed to be routine for the scientists at NASA's Solar Dynamics Observatory, SDO, turned into something extraordinary. At 14:32 UTC, the automated system monitoring the sun's disk brightness recorded a sudden, almost instantaneous drop in emission within one of the SDO AIA ultraviolet channels, 171 Orwell. This channel usually reveals the structure of the solar corona, bright plasma loops and active regions. But this time, the dimming wasn't localized. It covered an enormous semicircular region, about 1.4 million kilometers across, larger than Jupiter itself. Simultaneously, geostationary communication stations detected an anomaly in space at the altitude of SDO's orbit, a brief disturbance in the solar wind, and a measurable drop in photon flux in the Lyman spectrum. The team immediately understood that this wasn't a normal coronal fluctuation. The scale and speed of the event suggested something exotic. Over the next 29 minutes, SDO tracked the shadow's movement across the solar disk from left to right at about 150 kilometers, far faster than any known coronal diffusion process. Typical coronal dimming events, often linked to coronal mass ejections, CMEs, occur much slower and originate near active regions. They're accompanied by sudden bursts of energy, bright flares, or clear magnetic disruptions. This was different. There was no active region, no flare, no precursor, and most strangely, the onset was instantaneous, as if someone had turned off the light. At altitudes of several thousand kilometers above the photosphere, SDU's cameras captured a darkening that lasted around 12 minutes. When the light returned, it was 4% dimmer than before. That suggested not a transient event, but a stable shadow moving across the sun's face. The report that followed described it as a sudden emergent coronal shadow. Between 14:31:45 and 14:33:10 UTC, AIA data revealed a linear decline in intensity twice as fast as the spread of a normal coronal shockwave. The affected region covered roughly 0.02 of the sun's visible surface. Preliminary checks showed no corresponding changes in magnetic field lines, no bright loops, no plasma eruptions, nothing. That ruled out a CME or flare. Meanwhile, the EVE spectrometer detected a drop in EUV irradiance, and radio telescopes observed a simultaneous decline in S-wave emissions at 150 milliamperes. The effect wasn't limited to one wavelength. It spanned across the electromagnetic spectrum and even influenced nearby radio frequencies. The team entered emergency analysis mode. Could this be a calibration error, a shadow from the moon or a satellite? Every possibility was checked and dismissed. SDO was operating normally, power level stable, no instrument recalibration in progress. One log entry stood out. No indication of internal error. Brightness drop confirmed by secondary AIA 193 per channel. Mapping the shadow's path revealed something unsettling. The dimming began beyond the visible western limb of the sun, crossed the disk smoothly, and exited the eastern limb. It didn't appear from nowhere. It seemed to move across the sun, as if something massive had passed between the Earth and the sun, but at a great distance from both. Modelling the trajectory, scientists determined the object responsible must have been moving parallel to the solar equator, maintaining an angle of about 72 degrees relative to the Sun-Earth line. This wasn't a random crossing, it was a controlled path. Based on parallax and intensity data, the shadow's altitude above the photosphere was estimated at over 300,000 kilometers, far higher than typical coronal arcs, and its lateral span at roughly 1.2 million kilometers, almost the diameter of the Sun itself. No natural phenomenon matched this description. Typical coronal dimmings are hundreds of thousands of kilometers across and last hours, not minutes. This shadow moved too smoothly, too uniformly, and without any corresponding source of mass or gravity. 3 hours later, SDO detected a subtle but real anomaly in the solar particle stream. Magnetic field lines emerging from the region once darkened now showed a delayed particle flux, lagging by 14 minutes behind expected timing. Somehow, the event had not only blocked light, but also interfered with charged particle flow, something no known plasma structure could do. The radiation monitors confirmed a 5-7% reduction in local particle intensity during the shadow's passage. The only possible explanation was that something with mass and opacity, but of unknown composition, had moved across the sun's surface line of sight. When correlated with orbital ephemerids, No asteroid, planet, or spacecraft fit the data. It wasn't on any known trajectory. The conclusion, still unconfirmed, was quietly logged in a classified report. External transsolar object, characteristics inconsistent with natural plasma phenomena. Optical signature suggests artificial origin. By midnight, every observatory with solar monitoring capability, from ISE's solar orbiter to Japan's Hinode mission, was reviewing the data. The pattern matched across all instruments. A brief, coordinated drop in solar brightness, synchronized to within seconds, appearing as a moving shadow of impossible scale. Scientists tried to remain calm, rational, analytical. But one thing was certain. Whatever cast that shadow was real, enormous, and moving with intent. October 19th, 2025. What began as a routine night of deep sky imaging turned into something far stranger. In Chile, a group of amateur astronomers operating a 40-centimetre telescope under the Atacama sky noticed rhythmic dips in brightness coming from the direction of 3I Atlas, the interstellar object already under close watch after its unexpected acceleration weeks earlier. At first, they assumed it was simple atmospheric interference, clouds, vibrations, or an issue with their CCD calibration. But within an hour, identical reports emerged from observatories in Spain and South Africa, confirming that the fluctuations were not local. Every telescope, regardless of hemisphere, was detecting the same faint but consistent pulse, a 3.9% dip in luminosity occurring once every 67 seconds, then repeating with mathematical precision. The timing was too clean to be random noise. One Spanish observer, Maria Cortez, double-checked her instrument's clock, suspecting an internal timing bug. It wasn't. The signal was real. She uploaded her light curve to an international database, and within minutes the same pattern appeared in multiple independent datasets. By dawn, data analysts at NASA's Minor Planet Center had verified over 20 separate reports of synchronized light fluctuations tied to 3I Atlas's position. The rhythmic nature immediately sparked speculation. Natural bodies, comets, asteroids, even tumbling debris, can rotate or flicker due to uneven albedo, but such perfect periodicity across wavelengths and regions of observation was unheard of. One analyst from the European Space Agency noted that the dips were not merely reflective, but absorptive. The object seemed to be actively blocking or modulating light. In other words, it wasn't sunlight bouncing off its surface. Something was dimming the light as if filtering it through a structured field. Spectrographic data collected from La Silla Observatory in Chile added another layer of mystery. The periodic dips were accompanied by microshifts in spectral lines, subtle but measurable changes corresponding to interference in the hydrogen alpha and sodium D bands. These variations implied that whatever caused the flickering was not uniform, but rather composed of layers or panels with variable transparency. Within 12 hours, the phenomenon earned an unofficial nickname in the astronomy community, the pulse. Online forums lit up with discussions, graphs and theories. Some amateurs proposed that it was rotational modulation. Perhaps 3I Atlas had a geometric shape causing rhythmic eclipses as it spun. But models quickly disproved that idea. Based on its estimated rotation rate, shape, and orientation, the observed light dips didn't fit any plausible spin configuration. The intervals were too regular, too stable, and the amplitude too consistent. One researcher from MIT described it best. It's as if something near 3I Atlas is pulsing on purpose, not a random tumbling rock but a beacon. At NASA's Jet Propulsion Laboratory, analysts correlated the timing with previous anomalies from the Solar Dynamics Observatory 2 days earlier, the so-called impossible shadow. To their alarm, the pulse frequency matched the oscillations detected in solar irradiance after the shadow event, precisely 67.2 seconds apart. Statistically, the odds of two unrelated astronomical events sharing an identical timing signature were effectively zero. The team convened an emergency teleconference with ESA and JAXA specialists. Every dataset was checked, reprocessed, and aligned against background stars to eliminate error. But the pattern persisted, unwavering. As the night stretched into the next day, it became clear that the phenomenon wasn't transient. It was increasing in strength. By October 20th, the amplitude of the light dips had doubled, and a secondary modulation had appeared, a faint harmonic occurring every 2.1 seconds, synchronized with the main pulse. When converted to frequency space, the pattern resembled not a natural rotation curve but a structured signal, composed of hilling observation from radar analysis. The orbiting bodies appeared to be reconfiguring, changing formation. In the final hours of October 22nd, deep space radar picked up a shift. The smaller objects were no longer maintaining circular orbits. They were aligning into a linear chain, extending outward, a directed array now pointing toward the inner solar system. The rhythmic pulse continued. But this time, its origin wasn't random noise. It was deliberate, coherent, and aimed directly toward us. October the 23rd, 2025. For 3 days, astronomers had been tracking two phenomena that seemed unrelated. The colossal dimming field now referred to as the shadow, the same that had crossed the sun's disk on October 17th, and the rhythmic, structured pulses emanating from the interstellar object 3I Atlas. But that morning, new data from NASA's Near-Earth Object Coordination Center suggested something no one wanted to believe. Orbital trajectory projections showed a convergence, a precise geometric alignment between Earth, the shadow, and 3I Atlas. The model predicted that on October 25th, for a 6-hour window, the three bodies would fall into near-perfect collinearity. In other words, the shadow would move directly between Earth and 3I Atlas, a brief but total alignment. The probability of such a configuration occurring by chance was calculated at less than 1 in 50 million. Scientists from JPL initially suspected an error in the orbital simulation software, perhaps a rounding glitch or coordinate misfeed. But when three separate independent systems, NASA's Horizon Integrator, ESA's SOLEX model, and JAXA's Ephemeris engine, all produced the same result within a margin of 0.00003 astronomical units, the error theory vanished. The alignment was real, and it was imminent. The phenomenon immediately drew comparisons to gravitational lensing events, where massive objects bend and magnify light from background sources. But in this case, the mass and nature of the shadow were unknown. It wasn't a planet, asteroid, or dust cloud. It had no measurable infrared signature, no solid reflection, no emission at all. It behaved like an invisible curtain that absorbed or redirected electromagnetic energy on command. This isn't just lensing, one astrophysicist at the Harvard-Smithsonian Center for Astrophysics remarked during a closed conference call. This looks engineered. It's acting as if it's preparing to align deliberately. As orbital mechanics teams refined the model, they noticed a disturbing detail. The motion of the shadow did not follow any natural orbital curve. Its path contained small corrections, shifts in trajectory that could only be described as controlled adjustments. These deviations were subtle but statistically significant, as if the object was maneuvering to achieve the exact alignment. Even more alarming was the speed at which it was closing the distance. Calculations showed it had accelerated slightly since its initial detection, a near impossible feat for an object estimated to be larger than Jupiter's diameter. There was no known natural mechanism that could propel something that massive without producing detectable thrust signatures. Yet all instruments remained silent. No ion trail, no radiation bursts, no thermal spike. Just a vast, cold presence moving with impossible precision. By midday, observatories worldwide were reconfiguring to monitor the upcoming event. Infrared telescopes, radar networks, and even deep space probes were assigned to capture whatever might occur during the 6-hour window. But visibility was going to be a major issue. On October 25th, 3I's Atlas would be positioned near the sun's glare from Earth's perspective, making direct optical observation nearly impossible. Ironically, this meant that during the most critical alignment, ground-based telescopes would be effectively blinded. Once again, as during the solar shadow event, the key moment would happen unseen. "It's as if someone scheduled this alignment deliberately to hide it," commented an analyst at ESA, half joking but unable to shake the unease. Meanwhile, data from NASA's Parker Solar Probe began to show small but consistent magnetic anomalies, fluctuations in the interplanetary magnetic field corresponding to the predicted position of the shadow. These fluctuations had a repeating modulation that matched the 67-second pulse cycle originating from 3I Atlas. When scientists overlaid both datasets, a pattern emerged. The pulses weren't just being emitted, They were echoing. Each signal from 3i Atlas produced a phenomenon could achieve. As one senior analyst at JPL put it bluntly in his final report before the blackout, "The universe doesn't plan alignments, someone does." October 27th, 2025. The world was still recovering from the blackout during the alignment window when something even stranger surfaced. In Helsinki, Finland, a graduate researcher named Elias Korhonen, working under a modest radio astronomy grant at Aalto University, was running signal correlation tests on archived hydrogen line data. His task was routine, filtering cosmic background noise to calibrate an experimental antenna array. But at 0214 UTC, his spectrum analyzer lit up with a spike that didn't belong. It was a narrowband signal, pure, precise, and unmistakably artificial. Frequency 1420-440575-1 MHz, the hydrogen line. For decades, this frequency had been known as the waterhole, the universal channel for deep space communication, chosen by scientists worldwide because it was naturally quiet. Yet this wasn't background chatter or cosmic interference. The signal had structure, rhythmic amplitude modulations repeating in a perfect 67-second cycle. The same interval observed from 3i Atlas 2 weeks earlier. Elias froze. For nearly a minute he watched the line remain steady, unwavering, unlike any transient radio burst. It was narrow, only about 1 Hz wide, and coherent, as though locked to an internal oscillator. His first thought was interference, perhaps from terrestrial sources, satellites, aircraft, or even local Wi-Fi leakage. But the directional analysis ruled that out instantly. The source was deep space, coming from coordinates that matched the last recorded position of the shadow. Elias checked and rechecked his calibrations, even rebooted his equipment. The signal was still there. Then, at Orosu 21 UTC, it changed. The amplitude doubled, and a second harmonic appeared exactly 201 seconds later, the same secondary modulation previously noted in the 3i Atlas optical pulses. Whatever was transmitting, it wasn't random noise. It was patterned, deliberate, and repeating. Elias exported the raw data and ran a fast Fourier transform, FFT, to visualize the signal's frequency structure. The result nearly made him drop his coffee. The spectrum revealed nested peaks, not harmonics, but sidebands, evenly spaced in logarithmic intervals. To an experienced radio astronomer, that pattern screamed one thing: information. He immediately contacted his advisor, Professor Lena Hauke, who was skeptical until she verified it herself. Within an hour, they had rerouted 2 additional antennas from the Finnish meteor radar network to confirm the directionality. The signal held steady across all instruments. It was real, coherent, and extraterrestrial. By 04 UTC, Aalto's servers were overloaded with data. Elias sent his discovery to the International Astronomical Union's Transient Alert Network, unaware that within minutes his report would trigger the most urgent global communication blackout since the Cuban Missile Crisis. NASA, ESA, and JAXA all confirmed the detection. The 1420 MHz transmission was being picked up across Europe, South Africa, and parts of South America. Every telescope pointed near the shadow's coordinates saw the same narrowband pulse, repeating at precise intervals. What stunned scientists wasn't just the consistency, but the timing. The signal had begun exactly 2 days after the alignment window closed, as though waiting for the Earth to rotate back into position. And it wasn't broadcasting omnidirectionally. It was focused. The beam width was estimated at less than 0.003 radians, tight enough that only Earth's location would receive it. "Someone aimed this," said Dr. Javier Mendoza at the European Space Operations Centre. "It's not leakage, it's a transmission." Governments moved fast. Within 6 hours, national space agencies received classified directives to route all 1420 MHz data to secure servers. Public access to hydrogen line observations through SETIA Home, LOFAR, and amateur radio databases was quietly restricted. But the internet, as always, was faster. Amateur astronomers in Argentina and Japan had already shared waveform screenshots online before takedowns began. The world's attention shifted overnight from speculation to stunned disbelief. News outlets hinted at anomalous radioactivity, though the official line remained instrumental interference. Yet the data told another story. Analysts discovered that the 67-second pulse wasn't uniform. Each burst contained subpulses divided into 13 groups, each lasting exactly 0.418 seconds. When plotted as binary values, the sequence resembled structured data, not randomness. It repeated every 40 cycles, precisely every 44 minutes and 48 seconds, before resetting. The global scientific community had seen this kind of order before, but never from something so close and recent. The hydrogen line had been chosen deliberately. Whoever or whatever sent it understood human astrophysics and wanted it to be found. Meanwhile, in Pasadena, NASA's Jet Propulsion Laboratory fed the data through their Deep Learning Signal Interpreter, a neural network originally built to decode pulsar timing noise. After hours of processing, it produced a shocking preliminary result. The modulations followed mathematical constants, pi, e, and the golden ratio, and coded through amplitude phase variations. That meant the signal wasn't just artificial, it was intelligent. By the evening of October 27th, the world's major observatories were locked onto the shadow's coordinates. The signal's intensity fluctuated slightly, as though correcting for Doppler drift. Then, for a brief moment at 2117 UTC, an audio spectrogram revealed something that changed everything. Within the static, an audible pattern emerged, rising and falling tones like a sequence of musical notes separated by intervals corresponding to the Fibonacci sequence. It was as if the transmission wasn't just carrying data, it was composed, structured, intentional. The debate exploded behind closed doors. Was it a message? A calibration beacon? A warning? SETI's lead scientist, Dr. Marcia Alvarez, urged caution. "We're not decoding meaning yet," she told an emergency session. "But whatever this is, it's broadcasting on the one frequency every civilization would recognize." Then came the strangest part. At 2302 UTC, during one of the transmission cycles, every receiver registered a sudden amplitude spike, 10 times the normal level, followed by silence. For 11 full minutes the signal vanished. When it returned, it carried an additional feature, a faint modulation at 8 Hz, below the hydrogen carrier frequency, too low to occur naturally in cosmic conditions. When converted into audio, it resembled a deep, rhythmic pulse, almost like a heartbeat. Analysts began to suspect that the signal wasn't coming from the shadow, but being relayed through it. Triangulation data from the Deep Space Network supported this. The true origin appeared offset, located directly along the vector toward 3i Atlas. That meant the two phenomena were connected, one broadcasting, the other amplifying. The realization chilled everyone involved. "It's a network," Elias said quietly to his professor when the final data came in. "They're using the shadow as a transmitter." Late that night, the US Space Force confirmed electromagnetic interference on several classified communication satellites. The interference bore the same 67-second periodicity as the hydrogen signal, but with increasing amplitude. Some analysts feared it was scanning, mapping Earth's position or resonant frequencies. For a brief 6-minute window, several satellites experienced clock synchronization drift, a delay of exactly 0.418 seconds, matching the subpulse duration. Afterward, the anomalies ceased. By dawn on October 28th, the hydrogen signal faded. Every receiver reported a simultaneous drop in strength, then nothing. The frequency fell silent. No trace remained except in the logs and the sleepless minds of those who witnessed it. Within 24 hours, every dataset related to the signal was classified. Universities were instructed to purge local storage under national security orders. Only fragments survived, screenshots, waveform images, and incomplete binary sequences shared by amateurs before the blackout. But those fragments told a consistent truth. Something intelligent had reached across interstellar space, chosen the hydrogen line, and pointed straight at Earth. Whether it was a message, a probe, or a test transmission, no one knew. All that was certain was that it came from the shadow, and that it stopped exactly when we started listening back. October 30th, 2025. Both 3 Atlas and the shadow slipped into the solar glare, swallowed by the sun's brilliance, hidden from every ground-based telescope on Earth. Officially, NASA called it a standard observational blackout. The explanation was neat, rehearsed, and technically true, Any object passing too close to the sun's apparent path becomes invisible to optical and infrared instruments for a short window. But that was only part of the truth. What the public didn't know was that the blackout wasn't just optical. It was radio, magnetic, and electromagnetic across multiple spectra. On October 29th at 23:47 UTC, several solar monitoring satellites began experiencing signal dropout when attempting to track either 3i Atlas or the region of the shadow. Deep Space Network stations in Madrid, Canberra and Goldstone all reported identical telemetry loss lasting 11 minutes and 22 seconds, followed by synchronization drift in their atomic clocks. The anomaly wasn't isolated. By morning, NASA's internal network flagged 27 similar cases, all tied to systems pointed near solar longitude 198°. That corresponded exactly with the shadow's last recorded trajectory. Yet when the press asked about it, NASA's statement was brief and sterile. No anomalies detected. Transmission interruptions due to standard solar interference. Inside Mission Control, however, the atmosphere was anything but calm. Engineers were staring at corrupted telemetry packets filled with repeating hexadecimal values. Not random noise, but ordered strings of numbers. One engineer, cross-checking with archived data from the hydrogen line transmission 4 days earlier, noticed something uncanny. The corrupted data matched the binary patterns seen in the signal. Coincidence was ruled out instantly. It was the same sequence: 13 repeating clusters, identical spacing, identical checksum. Someone or something was writing into NASA's data stream. Meanwhile, in the classified compartment of the Solar Dynamics Observatory, SDO telemetry team, analysts noticed an even stranger occurrence. Just before the blackout, SDO's ultraviolet cameras captured a single frame showing what appeared to be a faint, geometric distortion across the sun's limb, a hexagonal pattern of light diffraction, lasting less than 1 second. It shouldn't have been possible. Solar plasma doesn't form rigid geometry. The frame was quietly pulled from public data feeds within minutes. When amateur astronomers noticed the missing timestamp in the open archive, speculation erupted across forums and social media. "The shadow's still there," one thread read. "NASA just cropped it out." Within hours, NASA issued a clarifying post claiming that data compression errors were responsible for the missing images. But leaked internal memos told a different story. The hexagonal diffraction pattern had been confirmed by 3 separate instruments: SDO, SOHO, and the Parker Solar Probe, all recording at different wavelengths. The probability of identical compression errors across those systems was essentially zero. To outside scientists who caught wind of the anomaly, the geometry implied a structured object, not natural, not random, and not static. Something was reflecting or refracting solar light deliberately, but from what? The working theory, circulating quietly within ESA and JAXA, was that the shadow was not a single mass, but an array, possibly hundreds of synchronized bodies moving in formation. If true, it meant the dimming field first seen on October 17th wasn't a solid object at all, but an artificial swarm using optical camouflage to scatter sunlight. It also meant it could control how it appeared to instruments, and when. The blackout in that case wasn't just coincidence, it was an intentional disappearance. Around the same time, an internal transmission leaked from NASA's Goddard Space Flight Center. In it, a systems analyst named Dr. Nwosu reported unexplained mirror activity in the telemetry of the Solar Terrestrial Relations Observatory, Stereo A. When the probe lost lock on the shadow's coordinates, it began receiving reflected data packets containing its own previous transmissions, identical bit for bit but delayed by exactly 44 minutes and 48 seconds. That number triggered alarm bells. It was the same repetition interval seen in the signal. "They're sending it back," one researcher wrote in the report margin. "It's reflecting us." Whether the reflection was literal or symbolic, no one could say. The timing, however, suggested something with near-perfect synchronization capability, as though the shadow was not just absorbing and redirecting energy, but understanding what it received. By October 30th, multiple agencies had imposed communication lockdowns. NASA's solar data portal went into maintenance mode. ESA restricted access to live telemetry from Solar Orbiter. Even NOAA's space weather dashboards went offline briefly. When they returned, recent data was missing, entire hours redacted under the label transmission gaps. independent scientists began noticing another disturbing pattern. During every blackout window, Earth's magnetosphere recorded subtle fluctuations, low-frequency oscillations unlike any known solar wind signature. Magnetometers from Finland to Alaska picked up the same rhythmic pulse, a faint but measurable beat every 67 seconds, precisely the same as the hydrogen transmission cycle. It seemed to echo through the planet itself. Social media went into frenzy. "It's still talking," wrote one viral post. "We just can't see it anymore." For a brief time, even major outlets began to question the official narrative. Why were independent observatories being told to suspend operations? Why had NASA suddenly classified optical telemetry above certain wavelengths? The agency's response was consistent: standard interference mitigation during solar conjunction. But inside the walls of the Jet Propulsion Laboratory, a different story circulated. According to an internal log later leaked anonymously, NASA had received a second narrowband burst from the hydrogen line during the blackout, but it wasn't from the shadow's coordinates. It came from between Venus and the Sun. That meant the transmission source had moved, or multiplied. The burst lasted 17 minutes, then stopped abruptly. No official record of it exists. Only a handful of scientists saw the live stream before it was scrubbed from servers. One of them, speaking under condition of anonymity, described what she saw. It wasn't noise. It was structured, like a handshake signal. It looked like it was acknowledging something. That same night, several deep space communication antennas, including the one in Canberra, registered a transient carrier wave near 2 GHz, sweeping rapidly downward to 1.42 GHz before cutting out. The pattern matched an intentional frequency hop, a technique used in secure data transmission to avoid interception. The implication was staggering. The shadow wasn't just broadcasting, it was adjusting to avoid detection. As public attention waned due to the blackout, only a handful of insiders grasped the bigger picture. The 10-day observation gap wasn't to avoid interference. It was to hide what was happening in real time. A restricted memo circulated on October 31st under NASA's internal classification level Orion 6, stating, "Solar observation blackout shall remain in effect until object cluster exits glare zone. Current telemetry indicates potential re-emergence trajectory intersecting Earth's orbital plane by November 9th, just 1.2 days." In plain language, whatever the shadow was, it was coming back, and this time it would cross directly between the Earth and the Sun. But none of this reached the public. The last official statement released to the press simply read, "Observations of 3I Atlas and associated anomalies will resume after November 10th. No cause for concern." Yet within NASA, concern was all there was. The few who knew what was truly unfolding understood that the blackout wasn't about what couldn't be seen. It was about what must not be seen. The instruments were never blind. They were silenced. And as the world went about its quiet end of October, no one realized that in the dark between the Sun and Earth, something vast and deliberate was watching back.